What do you have so far?
X out of 7 ln times the parentheses equals natural log of y.
Okay, so what can we do now? What property do we have available now?
What we move down on?
1/7 x. Yeah. So when that 1/7 x comes down, is what our equation looks like. So how do we find the derivative from here?
Do you do that third
Uh,
rule?
yes, that's part of it. Do you see anything else?
No.
How many functions do you see on the right side?
2, 3.
I see 2. I see 1/7 x, and I see natural log of x squared minus natural log of x. So what's involved if I want to find the derivative of 2 functions?
Quotient rule? Or power rule?
Product rule.
Product rule?
Yeah. Okay. What's product rule?
It's f times g prime plus the like other version.
Yeah. F prime g plus f g prime. Okay. Yep. And what happens to the left side?
The left side f. Oh, it's like the y.
Yeah. What does natural log of y turn into?
Oh no.
There's an implicit rule going on there.
More than. You did a u thing?
Mm-hmm.
Okay.
So what's natural log of y's derivative using that rule there?
Would be y? Or just natural log?
So this is y here. Right? That's y. Then what's u prime? What's y's derivative?
Oh. 1.
1 over.
So 1 over y.
And then we need to include dy dx, right? Because of implicit. Hey Tim. Hey Lexi.
Hello.
How are you?
Good. How are you?
Good. I'm picking out this problem from tomorrow's worksheet. So this is a log differentiation problem. We take the natural log of both sides so that we can take advantage of the fact that we have property because we don't have a rule that can handle this particular format.
What would the derivative of x over 7 be? Or no, it would just be 1 side.
Yeah. Okay, product rule on this side here. Okay, do you apply product rule? Okay. So my u prime over u, x squared becomes 2x, natural log of x becomes 1 over x. That's my u prime, all over my u value.
Where did you get the denominator from?
Because it came from the rule for natural log of u, right? What's natural log of u's derivative?
U prime over u.
There we go, u prime over u. Because this is my u value, right?
Mr. Yang,
Yes.
how do you know when to use product rule?
Okay, we know when to use product rule when you have two separate expressions that are being multiplied with each other. You see how 1/7 x is a different function than natural log, and these are kind of outside each other, but they're also being multiplied with each other?
Yes.
Okay, and I'm asking for the derivative, so that's when we know we got to do product rule.
Thank you.
Mm-hmm. Okay, any questions up to this point here? All right, what's our goal here? We're trying to get what by itself?
X.
What's the problem say? We're trying to find what?
Oh, do you want here?
Which is the derivative, right?
One over y.
Yeah. Same thing as what? The same thing as
Multiplying it
by y, yeah. So multiply y to the other side. And then we can replace the y back in terms of the original equation. So what's y equal to? So basically, we want our derivative to be purely in terms of x on the right side.
Wait, what do you mean? Oh, we just do that.
But what can I replace y with?
dx?
Can I?
Or that whole, or that, like the beginning.
Yeah.
Like, 7.
Mm-hmm.
So what's the point of doing these? What's the point of doing these?
Finding derivatives. This whole semester is finding derivatives, which is just finding a slope formula for functions.
It's a tree over here.
Yeah, like I should ask them to cut it down.
Yeah.
It's like scraping against it every winter. Okay, how are you guys doing on Teams?
Pretty good.
Okay, so I have these problems here. I got a derivative inverse. I've got a derivative of logs, and I've got a implicit. So we can just go through these, or are there any other specific ones you want me to go over with you?
Whichever you think would be the most beneficial for the test.
Okay, well, these are all beneficial, so, because we're going to see one of each. Okay, let's try a derivative inverse at a point. Number 6. Let me show the steps and see if you guys can work through this. All right, so what's first?
Would you set the function equal to 2?
That's right.
Like f(x)?
So even though that looks like an x value, and it is, it's the x value of the inverse, but we know inverse and original functions are flipped around, right? So that's really the y value. So put the 2 in for the y value and see if we can get a 0 to show up. So replace 2 in for y, and then we want to solve for x. But it's not going to be factorable, so you got to go through a series of a little bit of a guess and check. So to make it easier to do guess and check, let's just bring the 2 over to the right side. So let's test values close to 0, see what x value can be. Okay. Does 0 work? Okay, if I plug 0 in for x, it's not going to quite give me, right? What about 1?
I think 1 would work.
Okay.
Oh, yeah,
1 plus 2 is 3, 3 minus 3, so we have x equals 1. Okay, all right, so that's the first step. What's next?
Find derivative.
Yeah. Okay, what's f prime?
Would be 3x squared plus 2.
Mhm. Okay, next step.
Would you plug in the x value we found, like the 1? So that, okay.
So now we can find the slope using this x value that we found, right? So we need this x value. F prime of 1 is equal to 5. So if the slope of my f graph is 5, then what's the slope of my inverse at 2?
Would it be 1/5?
It's the reciprocal. And to give you a kind of a visual picture as to why that's the case. So you have two functions that are different order pairs, right? One order pair is 1, 5, 1, 2, the other's at 2, 1. So imagine you had a function and its inverse. A function has a slope of 5, which means that the inverse is going to have a slope of 1/5. So these corresponding points will always be reciprocals of each other in terms of their steepness. Okay, how do you guys feel about this problem?
It's easier than the other ones. How do you know
So
the slope?
It says here, find the derivative of f inverse at 2. So derivative of a function is the same thing as slope at a point.
So once you find this once you find that value, is that the answer? Like, that's all you have to do?
That's right, yeah.
Okay.
But make sure you go further than this, right? If you just stop
Yeah.
here, then you're not finished yet. You gotta do the reciprocal.
Okay. Thank you.
All right, Tim, Lexi, you guys okay?
Say it again, please.
Are you guys okay?
Yeah, I'm fine.
Okay.
I understand.
All right, number 7. Okay, we want to find the derivative.
What's that equation like log A?
Yeah, yes, we definitely want to apply derivative, but is there something we should do before derivative? What about expansion properties?
Should we do the quotient?
Yes, a combination of product and quotient. So here is something that may help. If I have log of multiple terms multiplied and divided by each other, we don't have to we can kind of avoid having to go through each and every method. Just understand that you're going to have a combination of 4 different log terms here. anything in the numerator is going to be part of a positive log term. Anything in the denominator is going to be part of a negative log term. So okay, so you can, using this, does that help you know how to get this into, you see how there are 3 separate terms here? We want to get this into 3 separate log terms here. So any idea how we can do that?
You could make A and B too.
So I guess this is really kind of extended example. What if I told you that log of A over BC is just log of A minus log of B minus log of C?
Then A would equal.
So how can I split this up into 3 separate log terms if I told you this?
Could you raise the 4 over x squared to the 1 minus x to the 5th power?
Yeah, but then we're solving, right? We're not worried about solving.
Okay.
We just want to find the derivative.
Okay.
Okay, so how would you expand this? No clue. Okay. What if the 4 was A and the B was x squared and the C was square root of 1 minus x?
Can we just do that?
Mm-hmm.
Okay. I'm getting that.
Then what would that look like?
Log 4 minus log x squared minus log
Mhm.
log 1 and 1 minus x.
Mm-hmm. So I'm just giving you an example where anything in the denominator will have negative logs, and anything in the numerator will have positive logs. So this is kind of I'm taking the properties and just showing you a specific example of it. Okay, anything else that I can do to expand here? Do you see any exponents that I can manage or any radicals I can manage?
Could you move the x squared, like the square out in front of log for the second term?
Yep, that 2 can come down, right? Okay, anything we can do with that third term? Or maybe can I rewrite this expression?
Could you make it log 5 to the 1 minus x to the 1/2?
Mm-hmm. All right, so now what can we do? Thomas. Anything else we can move?
We can try to answer like ln A over B. Or wait, do we do the quotient rule or something?
Yeah, well, we can use the power property.
Or your power?
What can we do here? Anything we can do here? Maybe I can use this property here.
But yeah, we can do that one.
Okay, how would you do it?
It'd be 1/2 times log 5 and times, yeah.
Okay, log base 5 of 1 minus x. So these aren't multiplied. This is inside the log. Okay, so I think we have a rule that we can manage for all of these. There's our rule. So what would y prime look like here? Thomas, what do you think?
Um,
Okay. So let's match it up, right? What's my a and what's my u value?
Yeah, just do log 5. Okay, so we 1 over 5 ln 5 times 1 over 4.
Close. What's the derivative of 4?
0.
Yeah.
But wouldn't that just be 0?
Yeah, whole thing is 0.
So y equals,
And then we got to do the second and third term as well, right?
which one would we do? Do we do the same one?
Yeah, same, right? They're both same rule, right? Log base 5, log base a.
But what do we do for 2?
Just coefficient, right? What do you do with the coefficient?
Multiply?
Yeah.
So we do it at the end.
Oh, you just do it in the beginning.
Okay, 2 times 1 over log natural times 5. And then times 1 over x.
Mm-hmm.
And then after that you do 5 or ln 1 over ln 5 times,
The 1/2 is going to stay, right?
yeah, times -1 over, yeah.
Do it. Can clean up a little bit more. Okay, any questions with 7? Do you guys all see how it got expanded?
On the test, how much like cleanup will we be required to do after that we like find the derivative?
You technically have the answer.
Okay.
So I won't. Yeah, I think we're going to be, if you have some form of the derivative, if you have some form of the answer, you'll get credit.
Okay, thank you.
All right, others of you, are you guys okay? Number 7?
Yes, thank you.
Okay. Here's number 8. It's not on the sheet on that, so you may have to write this down here. Okay, so there's quite a bit going on here. What do you guys see? What do you see?
Implicit?
Yep, there's implicit, definitely implicit. Okay, there's 3 things I want you to mention. Implicit is one of them. What's another thing you want to be aware of? Something about that xy squared.
There be product rule?
Yeah, that's product rule. See how those are 2 separate terms multiplied together, product rule. So that's second thing. One more thing.
Would it be like the natural log on the left side?
Yeah. Let's see. What do we do with this?
Would you make it natural log of x minus natural log of root y?
Expansion. Right.
Okay.
So we want to expand this because we don't want to do a derivative with such a messy u value.
Okay.
So expansion is one thing, product rule is another thing, and then implicit is a third thing. Okay, so let's expand the left side first, and then we can worry about the derivative. Okay, so expand that side. All right, Thomas, so what is that going to look like when you expand that left side there?
Log x plus log root of y.
Okay, so look at this one here.
Is it minus?
Yeah, a over b.
Yeah, that's the-
Okay. All right, write that down. Anything else we can do with that square root of y?
Would you make it y to the 1/2, like power?
And then what can we do with that 1/2?
Like bring it out in front of the natural log.
Bring it in front. There we go. Now we're ready for the derivative. Okay, so we spent some time doing some cleanup on the left side, but now we're ready for the derivative. All right, u prime over u for the two left terms. Oh, how many y terms do you count? How many y's do you see? So that means the next line will produce 3 separate dy dx's. Okay, all right, try that. So what's each of the derivatives?
For the negative 1/2 natural log of y, do you leave the coefficient out in front when you take the derivative?
Yes, just leave the coefficient hanging out in front.
Okay.
Okay, Thomas, what'd you get?
You should get 0 for L1.
What's natural log of x's derivative?
1.
U prime over u.
Oh, we're doing x?
Yeah, so x is our u value.
Okay.
So what's derivative of natural log of x?
Something over 1.
What's x's derivative?
Oh, wait, no, not 1. X is derivative is 1 over x.
Yeah, 1 over x. Yeah. Okay. What's natural log of y's derivative?
1 over 1.
Times.
dy over dx.
Yeah. And then we got to step into product rule, right? So we got to f prime g plus f g prime. What's f prime?
One.
Okay. Times g, which is y squared, plus f, which is x. And then what's y squared's derivative?
2y.
Okay. Do we need anything else after 2y?
Would you add the dy dx?
dy dx, right? Anytime we take y's derivative, dy dx. Good. How about negative 4y?
Would just be negative 4 dy dx.
Power rule for x to the 5th, 11 goes away. All right, so there's our calculus step, right? We did our expansion with the first few steps, we did product rule, and then we also involved implicit. You see how we have 3 y's here, and we have 3 dy dx's that pop up. So now we're just trying to put things together. We want all the dy dx terms on the left so we can factor it out and solve for dy dx.
Right, so we're moving everything to the left.
Yeah, move all the dy dx terms to the left. Yeah.
So this would be 5x forward on the right.
And 1 over x, and 1 over y squared. So these are the non-dy dx terms, right? The non-dy dx terms will be on the right side. Factor out the dy dx. and then divide the parentheses over. Okay, any questions here? Here are the test topics. First derivative test, concavity test, particle motion, velocity acceleration, creating your velocity sign line, acceleration sign line, increase and decreasing speed, increase, decrease velocity, finding derivatives, but sometimes that may involve expanding log terms. Know your rules for log base A and base E. Involving quotient, product, and chain rule, recognizing the need for that when it shows up. And then being able to find tangent line equation if I ask you, if I give you an order pair. Implicit, we just did that. Sometimes involving log expansion and product quotient rule. Log differentiation, we did as well. Find derivative inverse at a point.
She showed the whole sheet.
Mm-hmm. Let me see. Yeah, this link is also there under today's under this week. So links. Okay, see you, Thomas.
Thank you.
Mm-hmm. So I think we kind of hit on these standalone terms, standalone problems, right? So maybe it's helpful to go over some of these common mistakes that I see. If I have natural log of A plus B, it's stuck, right? I can't expand it like this. Sometimes students, they want to take that and they want to expand it, but this is stuck the way it is. Sometimes I see an issue where students apply, they apply a rule that doesn't match what's supposed to be done here. So sometimes sometimes I see students, they want to do power rule here. But see, that's variable raised to a variable, so I got to do log differentiation. I got to take the natural log of both sides. Okay, inverse derivatives. Oh, I see some students in the past, they would apply the rule for e to the u in interesting ways. So the rule for e to the u is e to the u times u prime, but I see more than one instance of this where they combine e to the u and natural log of u, and they say that e to the u is equal to e to the u times u prime over u. So That's not the rule for e to the u. It's just e to the u times u prime. There's no divided by u. Oh, this is also one too. Students expanding problems that's not a log expression. So sometimes I see this. Sometimes students see x squared y just by itself, and then they just turn this into natural log of x squared plus natural log of y. Okay, so we can't do that. We can't just expand something without it and just have. I mean, unless we take natural log of both sides, but we can't just magically separate them and include logs. And I see this as well. If I have natural log of u to the 4/3, I don't go through derivative power rule. Or sometimes students want to do chain rule from here. So they bring down the 4/3, they will subtract 1 from the exponent, and then multiply by the inside's function's derivative. So it's kind of like mixing chain rule and power rule, but really it's bringing down the 4/3 and then making it u prime over u. Okay, do you guys have any specific questions? Okay. So I have help session tomorrow morning during lunch, 5th period, second half of 5th period, and then also after school again tomorrow.
Thank you. Have a nice day.
You too. Have a good day, guys.
Thank you.
Bye.
Thank you. Have a nice day.
See you.